Now I have been using this term library so far, so you might have a question, what exactly is a library? A library is simply a collection of pre-written programs. These programs are already written, already tested and optimized for you to reuse them again and again in your program that you will write. So let me give you a real life analogy so that you understand this thing better. Suppose you are planning to bake a cake. First, you list down the ingredients that you will need for baking the cake, and you know that you will need flour, butter, sugar, and maybe chocolate and vanilla for making your cake. So what do? You order all these things from the grocery store, or you go there and buy these things for you. That makes things much easier for you, and you can focus on baking the cake that you want to make. Imagine if you had to make your own flour from the wheat and make your own butter from milk. That would have been very difficult, and it would take a lot more time to bake a simple cake, right? In the similar way, when you are writing your program, if every time you have to worry about the code for printing something on the screen or the code for taking inputs from the user, then you will not be able to focus on the logic for the program that you are writing. That's why these things are already written for you in the standard library, and you can reuse them again and again in your program. So you can think of the standard library as a shop where you can get free tools for using in your program. Now,
let's understand the program development process using something everyone knows, that is making pancakes. First, we decide what we want. Regular or blueberry pancakes, how many, any allergies, and what ingredients we have. And knowing the constraints, you don't start cooking without knowing the recipe.
The first step is problem analysis and specification. Suppose you are making pancakes for your family members. You need to know how many pancakes each one will take and what kinds of pancakes they want, the specifications like blueberry pancakes or chocolate chip pancakes. All those specifications you need to know beforehand. And you also need to keep in mind if someone has any food allergies. What are the ingredients that you have right now to make the pancakes? All these things come under the problem analysis and specification part. In programming, this step is about understanding the problem, defining the inputs and outputs, and knowing the constraints. In the next step, you will focus on finding a general solution for the problem. So this step is same as finding the algorithm for the problem that you are solving. So we will create a step-by-step procedure or the recipe for making the pancakes. Okay, so we will write down that first we will have to mix the flour, the milk, and the eggs, and then heat a pan, and then we will have to pour the batter, all these things. This is your algorithm, written as pseudocode or a flowchart. What is a pseudocode? It is a code or a program that is not written in a specific programming language. It is written in a generic way. I will show you how to write pseudocodes for problems, where you will just write things like, we need to take this as input, we will have to do this calculation, but you are not writing all these steps in a particular programming language. Okay, so that is your pseudocode. And you can also write flowcharts, where you will use different shapes to show what is your input, what is the calculation part, and what outputs you are getting, and then show a flow using arrows between those shapes and show how the problem will work step by step. So no cooking is done yet, only the planning part is done. That is your step 2. The third step is verification. Does the recipe make sense? Before cooking, we ask, what if the batter is too thick? What if the pan is too hot? In programming, this means checking if the algorithm works for different cases. We think all these things before we start cooking. Similarly, we need to think of all these things before we start solving the problem. Now comes the implementation step, where you actually write the code or you actually start cooking. We follow the recipe exactly as we have written and we do those steps. In programming, this is when we translate the algorithm into a programming language like C++ or any other language that you are using. This is where the code is written by the programmer. Now comes the testing and debugging. This is where we taste and fix things. So after you make the pancakes, you taste a little bit and see if it is too salty or if it is burnt, if it is not fluffy enough. So you check all these things and you adjust the batter and you make new pancakes, right?
That's not good. I need to add some more milk to the batter.
Same thing happens here. When we write a program, if the program is running properly, then we are good. Otherwise, if we are not getting the output that we expected, or if there are errors, those things are fixed at this step. There is one more step, which is maintenance and improvement. This helps us in making the pancakes better next time. So if we want to improve the recipe, if we want to add more ingredients like chocolate chips or blueberries, or make it healthier, or change the quantities, all those things. In programming, this means updating the program, adding new features, optimizing performance. Programs, like recipes, evolve over time. So good programs are not written in one step. We need to follow all these steps to develop a good program. And all these steps are followed in the industry when a software development takes place. But obviously, when we are just learning and we are practicing small problems, we will not follow all these steps, like writing algorithms and flowcharts and all these things. But obviously, you need to go through all these steps very quickly in your mind at least, so that you do not face problems when you are actually implementing the code. So before you start writing the code, in your mind, you will have to think of the steps that you will follow for solving that particular problem through your code, or you need to develop a flowchart that these are the different things that I will follow one after the other so that I reach the desired output for this problem. If you do not understand the requirements for the problem, if you do not think of the step-by-step procedure before you start writing the code, when you will start writing, you will feel lost, right? So these are the steps that are very important for developing programs. We just talked about algorithm design. So what exactly is an algorithm? Let's try to understand that. An algorithm is simply a step-by-step set of instructions to solve a problem. Just like a recipe that tells you exactly what to do in order, an algorithm also tells a computer what steps to follow. A good algorithm has a few important properties. Let's try to understand those properties. First of all, it must finish after some steps. Otherwise, we will not call it an algorithm if it cannot finish. Every step in the algorithm must be clear and unambiguous. So if there is a step in the algorithm that is vague, that is not very clear, then we cannot consider that step as a step of the algorithm, because we cannot have anything unclear or ambiguous in the algorithm. It may take inputs, it may not take inputs as well, depending on the problem that you are solving, and must produce some outputs. Every algorithm should produce some outputs, otherwise that algorithm is of no use, right? And each step in the algorithm must be practical to perform. There should not be any step that is impossible to perform. Okay. So before we write code, we first think about the algorithm, because code is just an algorithm written in a particular programming language. Now, if we really want to think like a programmer, we need to understand two big ideas. One is syntax and the other one is semantics. Syntax is basically the rule of writing a code in a particular programming language, and semantics is the meaning behind what you wrote. Let me give you a fun example here to make you understand these two words. Let us take the context of a theater. You might have heard about this famous play by Shakespeare, Julius Caesar. In the play, Caesar is betrayed by his friend Brutus. When Caesar is stabbed by his friend Brutus, he says this famous dialogue, "Et tu, Brute?" which means, "You too, Brutus." At this point, Caesar is shocked and heartbroken that his friend Brutus betrayed him. Imagine you are an actor playing this Julius Caesar. You have memorized your lines in the script, that's your syntax, and you delivered the line perfectly, just as it is written in the script, in perfect English language, with proper pause where the comma is, and making it sound like a question because there's a question at the end of the dialogue. So, no grammatical mistakes, nothing off, just exactly as it is written. So, you are syntactically perfect. But when you are delivering it, you start laughing and dancing, just like the Caesar in this picture. Then you will totally ruin the semantics, that is, the emotion and meaning behind the line. Your audience were supposed to get emotional at that line, but they will be totally confused, like the confused Brutus in this picture. In programming also, we need to pay attention to both syntax and semantics. Syntax is the grammar, the structure, the punctuation. If you forget a colon or use the wrong brackets, your code breaks. But the good thing is that in cases of syntax error, you will get a compilation error most likely. So you can rectify it easily. When we say a code compiles, we mean that it is grammatically or syntactically correct. It follows the rules of the programming language and the code is ready to run. That means when the computer reads your code, it doesn't get confused by any spelling or punctuation mistakes. It understands what you are saying, and at least in terms of structure, even if it's not the meaning that you actually intended. On the other hand, semantics is the logic. Even if your syntax is perfect and your code compiles perfectly, your code can still do the wrong thing if the logic is flawed. For example, you wanted to find the largest number from a list of numbers given to you, but your code finds the smallest one, or something like that. You will be happy that your code compiles and runs and it gives you a result, but it is not doing what it was supposed to do. Therefore, you need to do the actual brainstorming here, in case of a semantic error, to find out why the code is not working as expected. This is very similar to writing a grammatically correct sentence in a grammar or spell checker. Everything looks perfect, but the meaning might still be wrong, and the spell checker or the grammar checker will not be able to tell that. For example, let's say you meant to say, I prefer coffee to tea, but you accidentally write, I prefer tea to coffee. These two lines have exact opposite meanings. In the first one, you meant to say, you like coffee more, but the line that you wrote says you like tea more than coffee. And this sentence came to my mind because I myself used to get confused with the preposition use here as a kid. That's why both syntax and semantics are equally important if you want to write code that actually works as intended. Now I will briefly introduce two more terms, headers and libraries, before we end this video today. I will be using these two terms while writing our programs in the future. So just to get you habituated with the two terms and give you some basic concept on the two terms, I am explaining these two. So think of headers and libraries like a menu card and a kitchen. Okay, a header file is the menu. It tells the compiler what is available, what functions and classes exist. For example, when you write the line #include IOStream, you are telling the compiler that I plan to use cout in my program. The preprocessor simply pastes this information in your code. Okay, so that line #include IOStream is for your preprocessor. That is the part of your menu. So these are the things that I will be using in my program. But a library, we already talked about library a little bit. A library is the kitchen. It contains the actual code, the machine instructions that do the work. This is the code that really makes cout print something on the screen. The linker connects your program to the kitchen, so your order from the menu can actually be cooked. So remember, header tells what exists and libraries do the actual work.
These are all the concepts that I wanted to cover for your lesson 2. See you again in the next lesson.